If you walk into a university physics department today, you will find a strange contradiction. The mathematics we use to describe the universe relies on a rigorous, process-based framework, yet the way we first learn mechanics is rooted in a century-old, substance-based picture of reality. We are taught in introductory classes that energy is the capacity to do work. That definition functions well enough for pushing blocks up inclined planes, but it completely breaks down when applied to the mechanics of quantum and relativistic regimes. The pedagogical shortcut leaves us with a persistent cognitive error. We instinctively imagine energy as a hidden physical fluid stored inside inert objects, much like electrical charge held in a container. On the other extreme, when that fluid metaphor fails, it is tempting to dismiss energy entirely as a mere bookkeeping label, a mathematical fiction with no physical referent at all. Both instincts miss the mark. Modern equations demand we recognize energy as a rigorously defined quantitative feature of physical systems, one that actively measures, constrains, and balances continuous physical change. To see how this works, we have to adjust our baseline assumptions about reality. The universe does not consist of a static inventory of objects that occasionally undergo motion. It is better understood as one single, ongoing field in act. What we perceive as solid, isolated things are actually highly localized, stable patterns of co-change within this continuous field. These stable patterns do not possess energy as an internal ingredient or an added fuel. Instead, energy operates as the mathematical currency of this field. It is the strict quantitative ledger by which all physical transformations are balanced and recorded across interactions. To understand what energy truly is, we have to discard the concept of static objects entirely and look directly at how energy functions within the foundational equations of relativity and quantum mechanics. The first major step away from the substance view occurred in 1905, with Albert Einstein's formulation of mass-energy equivalence. The equation E0 equals mc squared is often misunderstood as one mysterious substance transforming into another. It actually states a precise proportional relationship between rest energy and rest mass. Einstein's specific argument demonstrated that if a body at rest emits energy as light in opposite directions, its mass decreases proportionally, without the body recoiling. This proves that mass is not a box holding an energetic fluid. Rather, mass itself is a direct measure of energy content. Inertial mass registers precisely onto the quantitative account of what a physical system is capable of doing dynamically. In the relativistic framework, a body completely at rest is already an active participant in the energy ledger. Its mass is simply one specific, measurable expression of its structural process. 11 years later, the general relativity field equations expanded this ledger further. Gravity responds not to a simple amount of mass, but to the full stress energy content of a system. This diagram shows a gradient color map representing spacetime geometry, where the stress energy tensor encodes energy density and pressure. This geometry isn't an invisible rope pulling objects. Instead, it writes an uneven rate structure, dictating clock speeds and guiding freely falling bodies along precise geodesics. We do not directly observe spacetime geometry as an independent object. The geometry is strictly a formal summary, while the underlying physical reality consists entirely of these lawful relations among changing processes.
Gravitational curvature is a mathematical record. It tracks exactly how energy differentially organizes the tempo of change across the universe. Moving to the quantum scale, the process-based nature of energy becomes an undeniable mathematical mandate, beginning with Erwin Schrödinger's 1926 formalization of wave mechanics. The time-dependent Schrödinger equation governs how quantum states change. The central component of this equation is the Hamiltonian operator, a mathematical matrix or differential operator that corresponds to the total energy of the system. In classical pedagogy, one might assume the Hamiltonian represents a static amount of fuel sitting inside a particle. The mathematics require a different interpretation. This mathematical expression is the unitary time evolution operator. It dictates how a state transitions from one moment to the next, and the Hamiltonian acts as the mathematical engine driving time forward. In standard quantum formalism,
Energy is not something a system passively holds. Through the Hamiltonian, energy is the formal principle that actively orders how a system evolves. This diagram shows a quantum state represented by a rotating phasor, essentially a clock hand on a complex plane. When a system is in an energy eigenstate, having a single definite energy value, its temporal generation is highly specific. A state of definite energy evolves through a simple phase factor, its energy dictating the precise rotation rate. In a superposition, distinct phasors rotate at different rates. These phase rates inevitably interact, producing the observable interference patterns and oscillations that define quantum mechanics. This clarifies the concept of a stationary state. It is not a state of absolute stillness, but a highly regulated regime where observable probabilities remain constant despite continuous internal phase evolution. Energy differences do not act as mechanical pushing forces. They are the rhythmic regulators that dictate the exact temporal articulation of quantum phenomena. Combining the lessons of the stress-energy ledger and the quantum phase generator, we must reassess the solid, macroscopic objects we interact with daily. A star, a clock, or a human body are not self-subsisting independent entities. They are enduring patterns of co-change that maintain coherence within the broader field. Identity and solidity are practical outcomes. They emerge when a local system successfully resists disruption or continuously repairs its organizational pattern. Stability in the universe is never the absence of activity. A stable object is a highly persistent mode of process, a localized equilibrium actively maintained by continuous internal transformation. The physical world is a globally articulated web of regulated processes. This diagram represents the final definition of energy. It is not the interaction itself, and it is not the physical process itself. Energy is the universally conserved quantitative feature that keeps the continuous changes of the universe mathematically coherent and legible. It is the common measure that binds the inertial resistance of mass, the gravitational influence of spacetime, and the unitary evolution of quantum states into a single formal structure. In a universe organized by continuous, structured becoming rather than hidden substances, energy is the ultimate currency that makes that constant change physically and mathematically real.